Uh, the next part would be embracing the local cultural heritage, architectural identity, as well as the vernacular building practices, because these practices have been owned over a long time, and these will help you sort of design for the place because they have been tried and tested over time. We obviously have to make and encourage sustainable choices in the design of the building, as well as by users through promoting walkability within the site, net zero cycles for energy and water, efficient waste management practices, etc. Today's workshop is also about net zero energy calculation and towards how can you achieve that through Revit. And the next thing that you would need to do is, because all of the sites are unique and you'll be choosing your own site, then you can define your own program and functions within it depending on the needs of the site. And needless to say, the spaces that you design should be accessible and inclusive, and they should be inviting for everyone. How do you go about selecting your sites? So either you can choose the RLDA list of sites that are attached with the design advanced brief, or if you're choosing your own site, let's say you have a site that you think needs interventions, that is the kind of intervention that is stated in the design advanced brief, but you cannot find it in the RLDA list, you can still pick the site, just that you'll have to justify the reasoning and the necessity of such an intervention. And the total site area should be between 3 to 12 acres. And the locally applicable bylaws will be used, or in case they are absent or you cannot find the locally applicable bylaws, you can use the National Building Code. You can also refer to the Manual for Standards and Specifications of Railway Stations, Volume 1 and 2, for the design of the railway station part for guidance. Here are some frequently asked questions about the competition. I'll quickly go through them. There is no registration fee for the competition as well as for the workshops. All of it is absolutely free. Can postgraduate students take part? Yes. Undergraduate and postgraduate students of architecture, design, civil engineering, and related fields can take part in this competition. Can the team members be from different colleges? Yes, inter-college teams, inter-batch teams, and interdisciplinary teams are also allowed, where at least one of the team members is an architecture student. Rest you can decide among yourselves, like whichever way you want to form your team. Can we define our area programs? Yes, because the sites are unique and you'll be choosing your own site, and depending on the scale of your the city that your site is located in, or the railway station that is serving that point of that part of the city, how big or small it is, that will influence the area program, and hence you are completely free to define your own area program. In absence of local bylaws, you have to use the National Building Code. And where will the workshops be announced? The workshops are announced every time on Instagram, as well as after registering for the competition, Design Advanced competition, you get the mail through, you get the notification through your registered email ID. So you can go ahead and register now for the competition if you haven't already. You can choose a site on your own, as explained a few slides ago. And are there more free workshops and design lectures? Yes, we are trying to have more design lectures and free workshops coming ahead. So please stay tuned. So as stated, the competition is open to all undergraduate and postgraduate students of architecture, planning, engineering, and design across the country, including those who have graduated in 2023, just this year. You are allowed maximum 3 members in a team. The registration deadline is 20th of October 2023, and the submission deadline is 27th October 2023. You have to go to www.designadvance.in to register yourself. Thank you so much. Over to you, Prakriti.
Okay, so thank you, Kanchan. Now, so yes, so you guys this is all about like railway stations, railway projects. So right, so we will be discussing about that, like how to go with the net zero building according to like with the railway station buildings, right? So how we can go for the energy analysis now in today's world, like in today's times, we actually need to need the requirement, like there's a requirement for the net zero building, right? So let's start with the net zero building. So right, just give me a minute, I'll share my screen. Right, so as we all know, in today's world, uh due to uh various challenges, the if I say according to the carbon footprint, right, the increase in air pollution, right, every aspect, right, according to that we need to go for a net zero building because it go if I talk about the result, right? So why we are going for the green? Because again, if we are not going for the green, the cost also increases according to maintain that building, right? If I talk about the maintenance of the HVAC load, right? So the if I say HVAC load or maybe heating, so, right? So because of that, the cost of maintenance of the building increases. So we are actually making it cost effective, and also it helps to if we don't do that because of the because of the harmful practice, right? So it is actually impacting on environment. So we need to go for the energy saving, right? So that is why for developing the while you are developing the building, energy analysis is necessary, right? Now, how we can go for the energy analysis? Like, what is the methodology, right? So static calculations or estimates are still being used. So this is the current methodology, and time take which is actually time taken and costly, right? And also difficult to use and interoperability, right? So, right now, if I talk about like to see, if I check how to calculate the energy analysis for developing a net zero building, because net zero building, one aspect is the energy analysis, right? So in full project cycle from conceptual design to maintenance, the energy analysis is actually holding an important role, right? So why we are going for the net zero? So as I read this, so net zero NSZ building is actually building with net zero energy consumption. So as I told you, energy analysis actually plays over here as the major role. So we have like passive design strategies, active design strategies, how we can incorporate in the building to develop the sustainable buildings, right? Now, if I talk about different design strategies, so one is your passive design strategies, in which you go for different sharing devices, right? And even you provide uh, good spaces more water bodies, more like planting, like planters, like more forestations, right? More greenery, so that actually it helps you like a good ventilation inside the space, inside the rooms, right? Now these are just like these are just passive strategies, right? Passive design strategies, which are of low cost, right? And they are actually permanent, right? So if I talk about the active strategies, in which you need photovoltaic panels, like solar panels, right? Which is actually necessary for converting the solar energy to electrical energy, right? To so that like all the appliances will be using those solar energy, right? Now if I talk about, if we don't use this active design strategies, your heating load, your your consumption of energy also increases. So these are the basic strategies that we actually incorporate in a net zero building. Net zero means we are actually consuming, we are actually going for the less consumption of energy. We are converting the renewable energy into the main energy for consuming in the building, right? But it is of like it requires maintenance, like it requires high maintenance. So in which level, like somebody told me, like somebody asked me, like in from which stage we need to go for the energy analysis, right? So if you are developing a conceptual stage, so you all are architects, like you all are like civil engineers, maybe architects, right? So if we are developing a building, from conceptual stage, you need to go for the energy analysis, because uh, we go for form follows function or function follows form, both ways, right? So energy analysis should be in different stages, like from the conceptual stage, from like when you are going for the design development, when you know like what kind of materials you will be using. In conceptual stage, that means like basic materials that you know, right? So materials, or maybe the like planning, right? And in the design development, and in like once your piping, like once your HVAC system has been installed, once your uh, full project has been completed, after that also you need energy analysis, because you need to show like once your project needs to be maintained, right? So how much energy it is actually consuming, right? You need to understand about that. So now, how Revit actually helps you. So, as I told you, in conceptual design as well as in detailed design, you have to go for the energy analysis to check, like from conceptual stage to construction, right? So, like conceptual means you are basically going for the uh just your form, how your form actually helps in your energy consumption, right? And if you are providing any maybe basic materials, right? So what will be the like if you go for like full concrete material, like, right? So concrete also emits heat, right? So how you will be managing your building, how you will be managing your uh, building. So at each and every stage you need to go for the energy analysis, from conceptual design, detailed design, and as well as last in the construction stage, right? So, right now, what is the benefit? Like, as I told you, in early stage, conceptual stage, we need to go for the energy analysis. Now, what are the benefits for that? So, first of all, it actually helps you to go for the modeling, right? You can actually enhance your modeling part. You can actually choose materials according to the uh, energy analysis, like what materials will emit less heat, less amount of heat, right? Which will make your internal interiors cool, right? So So now you may compare performances of alternate design strategies, like different design strategies that I told you, like passive and active, right? As well as energy design, stage design decisions have great impact on building performance. So again, like building maintenance will be easier if you go for the stage, like early stage analysis, right? Now, the next thing is the building orientation. As I told you, like passive design strategy, one is the main thing, that is building orientation. How your building is oriented so that your like you will get the we can say, like if I say your interiors, right, you will get the cool breeze, right? If you have the like orientation which is actually adjacent to your green areas, green spaces or water body, right. So building orientation actually helps you to go for the energy, like passive technique. It is actually passive design strategy, right? Now, how the Revit actually works.
Integrated analysis and modeling.
So there's a video for you to understand like how the energy analysis actually helps like in Revit, how it actually helps you. So just give me a minute.
Analysis and modeling, better design and performance. Use architectural models at any level of detail and completeness to quickly create accurate, analytical geometry. This is especially valuable for enabling systems analysis from the earliest stages of design, staying in sync with architectural development. This is the same analytical model used by Autodesk Insight, which now includes extended climate data, envelope material thermal, and building space type data. Capture HVAC system design intent with a simple sketch tool, attaching smart system objects from an extensive range of types to define which systems serve what regions of the building. This forms the basis for analysis, as well as downstream coordination, documentation, and detailing. Use Revit views and schedules to validate the model before analysis, and explore model outputs in graphical and tabular form. Powered by Energy Plus and built using the OpenStudio programming interface, Revit Systems Analysis ensures high trust and confidence and provides total transparency into how analysis is run and, critically, the ability to create custom workflows. This opens the door to much greater analytical physical workflow automation and whole building and system design optimization. Discover Revit Systems Analysis, integrated analysis and modeling, better design and performance.
Okay, so now you got my point, like how this like how in Revit, how energy analysis or any other analysis, like structure analysis, how actually it helps, right? So if you are going for the building from scratch, and like as I told you, like a BIM procedure, in BIM workflow, Revit actually plays an important role, right? Where you are developing a central model, and with that central model you are generating multiple of documentations as well as analysis also. So why we are actually emphasizing on analysis, so that we can actually help to create different sustainable developments, right? Sustainable buildings, right? As well as net zero buildings, so where we actually go for the zero consumption of energy, right? So that is why we need analysis. So once we are developing the central model in the Revit, we are actually going for the energy analysis as well, like solar analysis, shadow analysis, and then illuminance analysis, right? And then heat load calculation. so that we can actually control like how much, like according to the tonnage, right? How much, like how to control that heat load that we are getting in the building, right? So we can control it. Right? So let's talk about the sun settings. First of all, sun settings like shadow analysis. Shadow analysis actually main thing. Like if I talk about according to the location, like right. So building orientation will be according to that, right? So sun analysis are actually major important thing where we actually go for the sun path like sun path direction, right? And this will help you in developing your shading devices, like where the major, like where the sun shading devices are mainly used, like at what point, like at what orientation we need more shading devices, right? So the shadow analysis actually needed over there. So first of all, you can actually go for multiple shadow devices, like multiple day. Let's say if I talk about a time lapse between like from morning to evening. So how your building will affect, right? According to the sun path direction. What is the location? The location of the direct like sun path, the location is actually major important thing over here. So we have different solar studies over here, winter solistic and summer solistic. So according to that, you can change the information. So if I talk about the project, so we have the railway station building. So over here, you can see this is the BIM model in which it is actually developed in parts. One is site model and one is main Revit model. Right? Now, what we need to do, what we need to do, we need to go for like if I say how, like first of all we need to set the location. As you can see, we have provided the solar panels as well, but we need the analysis, right? So solar analysis, daylight analysis, we need those, right? So first of all, so I'll share my Revit screen, just yeah. So yeah, so this is the project that we are like that we have for the railway station building, right? Now, first of all, we need to set the location. Location is the main thing over here. So if I go to manage tab, project location panel, location, over here you can go for the exact location. So now this site is actually in Manipur. So that is why we have provided over here. So if you have the site coordinates like latitude and longitude, if you have those, you can search it or you can just type it over here. Let's say Delhi. Like this. So where is your site located? You can actually mention it over here, and you can see the latitude and longitude are actually over here. So if you know the correct uh, coordinates, then you can use like then you can actually copy paste over here. Otherwise, you can just search it around it over here. So this site is actually in Manipur. So let me research it. Right, so Manipur, India. So I'll go for like search over here and let's specify like where my site will be placed. So over here, so the sun direction sun path will be uh, according to the location, right? So if I click on OK, once the location has been set, now it's time for the solar energy, like like shadow analysis first. So what I'll do, I'll just go for hidden view so that you can see like this is the conceptual stage. If you have provided a form, right? You want to provide the shadow analysis. So better like to go with the hidden view side, right? Now we need to turn on the solar settings as well as the sun path direction, right? So if I go for sun path, sun settings, now over here you need to specify, like right now you can see the location is coming over here according to what we set, right? What we like what we provided in the like previous, right? Now this is according to you. Like if you want to check the time lapse, right, from morning to evening, you can actually go for single day and you can go for multiple days as well, right? But if you want to go for the maybe let's say whole day for the summer solstice, right, or maybe winter solstice, so you can actually go for the solar studies as well. So all the information is actually provided over here, right? So if I go for like summer solstice, so you can see the date and the time is actually calculated over here. It is actually by default created. If you want to create your own, let's say according to maybe different falls, right? According to rainfall, according to any like, right? So you just need to create the study over here. You can duplicate it and then change its information, right? Now this actually is used for the time lapse. So if I go for still is actually for one, like for a time, like for a period of time, like you are giving a time, specific time. So if I click on apply, so you can see we have latitude and longitude. If you click on three dot option, it will give you a big map again. You can just go for the project address, right? And then you can see we have the weather stations around it. So this actually helps you in giving the HVAC like analysis as well. So let's not talk about that. So let's click on OK. And now if I go for apply, click on OK. Right now it is not giving you anything because the shadows are off, right? And the sun path is also off. So what I need to do, I need to just go for sun path on, right? And you can see the sun direction, like sun path is actually according to the location. That is where the location is most important thing. And now for the shadows. So now if I go for, like you can see, after we have sun settings, we have shadows. Okay? So you can see like how the shadow direction is actually over here. Like now the direction of the shadow, we all know, like it is 45-degree angle, right? So for that, when we change the sun direction, right? So if I change right now, it is actually in today's date, right? Today's time, today's date, today's time, right? So now if I want to change it, I can change it over here. So let's go for maybe October, right? Or you can change the time over here. Let's say like in maybe evening time, how the shadow is actually working, right? So you can see like we need daylight. So wherever like daylight is actually important, right? So that we can actually go for diffuse daylights, right? That is why the shadow analysis is actually necessary. Like if we are working on the group housing buildings or any kind of buildings, so daylight, like if the interior space is actually lit up by the daylight, that is way more effective than the artificial lighting. So artificial lighting load will get deducted, right? So that is why the daylight analysis is actually important, right? So if I change the time over here, so you can see, right? And like towards the winter portion, towards the summer portion, you can actually check how the sun, how the shadow is actually working. So this is actually a still like uh still like one day. But if you want to check the time lapse, so how we can actually go for the time lapse? Right. So for that, now I'll go for solar sun settings and then single day. So from over here, sunset to sunrise, we need to provide 1 day interval, like that is up to you, right? So let's talk, let's go for the maybe from which time, like from 7, like from 5 a.m. to maybe 6 p.m., right? Like that. So let's provide it. Right. So let's go for 7 p.m. Sunset to sunrise, or we can go for that. It will take automatically the information, right? So now, if I go for save settings, you can actually, in the end, like you can create your own study as well. Because, like, if you want to share this project to your team member, they can actually go for this same setting, and then they can actually go for the major like daylight analysis for different stages as well, even for different projects as well, right? So let's click on apply, and then let's click on OK, right? So now, right now, you can see we have created the same a full study, right? Now we can export it as a sun video as well, like sun analysis, like daylight analysis as a like animation as well, right? So that we can actually create a time lapse. So if I go for file tab, export, and then images and animations, and then we have the solar study. So we are actually generating the solar study over here. We need all the frames. So this is actually related to the settings for the video, right? So if I click on OK, we can include the date and time stamp. This is actually important to know, like from where to where, like from which time slot you have taken the solar study. This is actually to create your solar study analysis, right? So let's click on OK. And let's save it in maybe desktop. So this is main model, solar study. Click on save. Now you can see it is actually creating a time lapse, right? So let's wait and see how the video will come out, right? So let's wait. Okay, so now the time lapse has been created. Like now let's see how the result is actually there, right? So I'll open my video. So as you can see, it is actually way faster than like, because the time like frame per second is actually huge, right? So that is why like you have to set the time limit as well, right? So you can see the difference. So it is actually for the whole day, like one full day, right? you can go for multiple day, as like there's one question, if I read it out loud, like, so there's one question over here, uh, which is asked by Mr. Puneet. Like, we have we can see the shadows and lights at a particular time, or like it can access optimal analysis over the whole day or month. So as I told you in this, like it is actually created in the this is actually for one day, but for whole month also you can develop it, because we are creating the study, multiple studies as well. So multiple day study you can create as well, right? So time lapse can be created for our whole day or for different days as well, like multiple days as well, right? So yes. So like if I want to increase the time limit, so I can just go for the export. Now I need to go to where you have per second frames. How many frames I use. So how you can actually see that? So if I go to any solar settings, you can see over here we have 13 frames. So frames per second is actually 15. That is why it is actually your video is actually faster. So you actually need to control that. So if the time interval is like maybe 15, so it will be much small, slower, right? If you want to preview it, you can also do that, right? So frame per second is actually major thing to make your video faster or slower, right? So if I click on OK, and if I go for, like, you can see we have this preview solar study. If you don't want to export it, you can just go for the preview option over here, and then you can play it over here. So you can see. Right, so this is like this was all about the like solar like shadow analysis, right? Now if I talk about as you can see, like the timeline has been created, right? You can export it and share it to your clients, share it to your maybe like teammates, right? So this is in the first stage, right? First stage, because you are designing right now, right? So that is like how you can develop, how you can actually see what is the correct building orientation for your project, right? So next is the solar analysis. So solar analysis, if I talk about like how much direct heat gain is actually coming, like direct solar energy, like solar radiations, right? Solar rays, right? Sun rays, where it is actually falling. So this is actually required for the active design strategy. That means if you are providing solar panels, right? So where is the perfect location for the solar panels? So if I show you, this is actually color coordinated, right? So it actually helps you for the solar radiation potential, like where the sun rays are actually maximum and medium. So wherever there's a medium, like wherever there's a like blue shade, that means it is actually cooler side of the project, right? And wherever it is maximum, there you can actually provide the solar panel. So this is actually helpful for you for to develop the active design strategy, right? So you have to use the surfaces on the model, right? So like whatever, like maybe walls, roofs, ceilings, right? And conceptual masses as well. So if you have like solar panels with you, so like solar panels will be placed on a platform, right? So you need to go for roof level. If you are providing solar panels on roof, you have to check the solar radiation for that surface first, right? For that building first. where the location of the solar panels will be best, right? So it will give you a full chart, like in kilowatt per hour, like kilowatt hour per meter square, like what will be the solar radiation over here, like what will be the solar analysis, right? So how we can actually go for that? So for solar analysis, it is mandatory to like to install a plugin, right? So inbuilt solar analysis is not there. So if I open any version, that is maybe any version, if I go for like maybe 21 or 22, you can see like in analysis, like we have to install the uh, solar analysis first. So just give me a minute. So as you can see over here, the like you can see over here in energy analysis panel, the analysis panel, energy analysis, these two parts, lighting analysis or solar energy analysis. This is actually installed by plugins. Inbuilt, you won't find in any version. So I have in 22 version, like you can see in 22 version, I don't have that panel, energy analysis panel. So whenever you install it, only then like you will be able to develop it, right? So these are not plugins, these are add-ons. So when you go for the installation of Revit, you have to check the these add-ons as well, right? So this is the major thing, right? So solar analysis and lighting analysis is the name of the plugin. So how this actually works? So let's see first. So if I go to the energy analysis solar, so you can see over here, like you can see, like right now, it is taking the study like 1,798 meter square selected. That means the area, the roof space, like where you want to provide the solar analysis, solar study, right? So if I go for, look, you can see over here, annual PV, right? Solar energy, right? So you can see we have different kind of analysis, right? So according to like what you want to provide, like average installation, like peak installation, or so how much peak it is, right? So for photovoltaic cells, for solar panels, what is necessary? You can change the units as well according to the requirements, right? So if I want to select any surfaces, right? So first of all, I need to select the surfaces, right? So I'll go for the hidden view, because I can see the like color coordinated 3D view, right? That is why. So first of all, I'll do one thing. I'll just duplicate this view and go for the solar study. Right. Now I've created the solar panel, solar study over here, right? So what I'll do, I need to go for the energy analysis panel, analysis tab, energy analysis panel, solar analysis. And then you can see over here, we need to select the surfaces first, right? So surfaces, like where you want to provide, like you can see it is written, click to select space, like faces, then click finish to the left side over here, right? Now what, like where you want your solar analysis to be done, right? On the roof surfaces and walls, right? So to check like where your maximum heat gain is actually coming, like where you have maybe like maximum solar radiation, right? So once this is done, so you can see over here, let's go for finish. So once you hit the finish, it is getting upgraded, like updated, right? Now it is actually user selection. So first of all, I need to check, like, do you want to daily and like go for the day on daily basis, or maybe hourly basis, or an annual, like full year, right? So that is up to you. So let's go for annual. So let's go for update. So it is giving me like for the analysis, like what part is actually maximum, like containing maximum solar, right? So you can see the location of the project is actually Manchester, right? So according to that, you can see for starting daytime and ending time, you can have the solar analysis annual, right? And insulation CSV means you can actually export it as a chart. Like if I go for export option. So if I go for like maybe desktop solar study, and let's open that CSV file. So it is actually giving you for each and every surface that you have selected, like what are the like solar average insulation value, like how the like solar will be insulated, right? So if the insulation value is higher, then the direct heat gain, direct solar radiation won't enter, right? So total, like you can see, study date range, study date time. So everything is actually giving you a report, right? So as you can see, it is actually like giving you legends as well. So that is why I created a duplicate like view, solar study view, so that you can actually share it to your different consultants, right? And if you want to change the for not annual according to daily basis, you can go for that as well. So if I go for daily basis, so you can see it is actually updated. So whenever you change the style of your solar analysis, the timeline of the solar analysis, let's say according to the maybe hourly, daily, annual, so it will actually update on its own, right? So this is actually like necessary for placing the like different, if I say your different solar panels. According to solar panels, how the position of the solar panels will be decided according to the solar analysis, right? So this is actually necessary for you, right? Now, like somebody asked me that analysis period, like why it is always between 2010 to 2011, because this is the sample projects developed by the Autodesk. So the like timeline of the project, timeline of the solar analysis, sun direction, like sun settings is actually from 210, like 2020, 2010 and 2011. So that sun settings is already provided at that timeline. So you can change that also, because this is actually a solar study now. So sun settings, you have to do it first, and then you can go for the solar analysis after that, right? So that is why, like I told you, like you can create your own studies according to the current timeline, right? Right. So now the next thing we have is the illumination analysis, lighting analysis. That means how much light you have provided. Like if you have an interior space which has a daylight as well as internal lighting system, right? Artificial lighting. So how this actually affects your main space, main area, right? So let me open the PPT part first. So as I told you in illumination, like if I talk about the you like SI unit, like the unit, so it is actually lumens per unit area, refers to the amount of light incident on the surface. So if you have the reflective surface, how the light will actually reflect, right? So this is actually like a main thing. Like in office areas, this is actually necessary, right? So if you have the daylight, like if you have like artificial light uh, provided, as well as you want daylight as well, right? How it will reflect according to the surfaces, you need that, right? Now we have the building code requirements. So now according to that, you can actually provide your own like illumination values, right? So each and every reflective surface, like your if you are creating walls, right? You have wall surface like plaster, how much light if it will reflect your wood, right? If you are creating your doors, or maybe your floor finishes, how that floor finish will reflect your lighting, right? You have to provide those information first, right? And then according to that, your illumination analysis will be done, right? So how this actually will be done? So illumination analysis actually helps you to define the like amount of light actually entering the space, the main space, the interior space, right? And like let's say daylight factor and all, right? So you can actually calculate everything, right? Now this result you will be getting. So like how much, like if I talk about the maximum like blue light, right? So blue color depicts like there the this is actually darkest corner, like where your lighting is actually not affecting, right? Your daylighting is not allowed there, your maybe like artificial lighting is not coming over here, so that is actually dark corner, right? So you are actually going for the rendering over here, illumination rendering, right? So how it actually is over here. So,
For an illuminance rendering
so you
in
can see
Revit,
over here, like first of all, we need to specify the space, right? So if I go to Revit, so first of all, we need to go for any camera view, any perspective view that you have created. So if I go to maybe just so by default, the Revit actually follows the ASHRAE, right? So if you want to go for lead like standards, or maybe Griha standards, like specific standards, so you can actually customize it, right? So according to the heat load calculation and all. So let me select the views, like where we go for the energy, like illumination analysis. So I'll be using this one, right? So because we have daylight as well and the lighting system as well, right? So we can understand like from where we actually need the like maximum like artificial lighting as well as daylight lighting. So for that, if I go over here for lighting, you can see, right? You have to select the analysis first. So if you want to like, if I go for run new analysis, so it is actually creating an insight lighting model view. So let's see, it is actually loading. So you need to first provide the location, your illumination analysis, daylight factor if you want daylight factor, right? According to lead. So it actually gives you the lead, like according to lead specifications. But if you are going for the heat load calculations, like everything is actually according to the ASHRAE, right? So if I want to go for illumination analysis or maybe daylight factor, let's go for daylight factor. Uh, right? So now do remember, according to this, you need credits. You need credits, right? So these credits are actually available. Like if you are going for the like license, so these credits actually help you to provide the analysis. So right now, I don't think I have the credits. That is why it is not starting. But again, you can go for the like render, like illumination render over here. So let me open. Right. So what I'll do, I'll go for the view tab and then presentation plan like panel, render in cloud. I'll go for continue and then I'll select the illumination analysis over here. So there are two ways. If you go for the previous method, it will give you a full report, right? How much energy will be consumed, like how you will be using the like shading devices. So it will give you a report, a PDF. Like it will give you a report. It is actually linked to the Insight. Insight is another like Autodesk Insight. So I'll show you that as well. Like it is actually a video. So I'll show you that. Now, because I'm working with this view, so I need the illuminance. So you need to choose the location and time, right? And then let's go for start rendering. It is actually rendering it is actually rendering on cloud clients, right? So with different clients, then you can actually like share it online, right? If they don't have Revit, they can actually view it like from anywhere, from like anytime. They don't need Revit for that, right? So let's see how the rendering will actually is actually coming, right? So you can actually like if you are working in the project, your rendering will be uh, done on the background, so you don't have to like worry about the uh, like maybe we can say like any interruptions, right? So you can actually see over here in the view rendering process, or if the rendering is completed, then you can go for the render gallery to view like the illumination analysis, right? So let's go and see how the render is actually coming. Actually, for credits now, like for lower version, it is actually credits, but for higher version, like 24 and onwards, it is actually tokens. So, your rendering can be done without tokens, but like your illumination analysis, the one that I talked about, the insight and all, so you need tokens for that as well. So let's see how like it will be like let's see how the issue will be resolved. So right. So as you can see in the it is actually in progress, the rendering, right? So let's see how this actually works. Now, as you can see, this is actually according to the solar, like daylight. So we actually go for like went for day analysis, right? So as you can see, like it is actually full bright, right? That means like full daylight is actually coming over here, right? So if I go for the different renders, so if I go for different, maybe let's go for back. I've created a small render for you. So this is actually an office space. We have three different portions. You can see this is an office interior. So we have false ceiling over here. We have lighting system, and you can see like wherever we have like this is according to the daylight factor. So if you have the daylight coming, so where it is actually like major uh, lighting over here. So yellow means like it is actually brightest, and blue light it means daylight is not entering that space, right? So this is actually how you can create your analysis, right? Right. So this is how your energy analysis, like basic analysis, is actually done over here. But you can do heat load calculation as well, right? As well as like HVAC analysis also it can be done. Wind analysis can be done. So different analysis can be done. But for now, we have discussed till here, right? So if you have any other questions you want to discuss, let's see. But before that, I wanted to show you guys like how the insight actually helps you in creating the solar analysis with Revit. So let me share it with you. Just give me a minute.
Maximize your BIM workflows with Autodesk Insight, a powerful cloud-based analysis tool in the AEC collection. Autodesk Insight helps you improve energy and environmental performance throughout the building lifecycle by letting you integrate energy analysis, lighting analysis, and solar analysis for a holistic approach to building performance design. Make smarter design decisions using Insight's cloud-based analysis tools to iterate and optimize project parameters during the design phase. For example, use Insight to automatically create energy models from Revit, from concept to detailed design, access analyses and visualizations directly in the modeling environment. Visualize and interact with key performance indicators, factors, ranges, and specifications with real-time cause and effect feedback. Quantify and visualize heating and cooling loads. Perform sun and shadow studies to accurately see how lighting conditions affect your model. Simulate daylighting and glare. Access solar PV performance analysis quickly within design environments. Now you can clearly see and thoroughly understand multiple interrelated aspects of a building's performance parameters before construction. Insight extends the capabilities and value of the Autodesk AEC collection through unprecedented levels of cloud-based performance analysis. Discover Autodesk Insight and discover all the power of the AEC collection.
Okay, so as you can see, like how the Revit and Insight is actually helpful for developing the energy analysis, more like if I say more detailed analysis report, right? So this is for today. Like we had discussed about the energy analysis. So if you want to know all about it, if you have any questions, you can actually contact us, right? So I think some of you all guys like have some questions. Let's read that out. So um okay, so name of this code block, just say like if I say uh according to the NBC, it is actually like mentioned all the like National Building Code, it is mentioned like all the illumination, but the Revit actually follows the main like ASHRAE as well as LEED, right? LEED for the illumination. Now for heat load calculations as well, like it is actually it is based upon the ASHRAE codes. So you can actually look at the, up to like look at that. And like in our main course, like maybe BIM for design and other courses, like you will be understanding more about in detail like how we can go for the heat load calculation as well, right? So if you want to know more about the like how the load calculation is done, how the solar insight analysis can be done, so this actually like will be covered in the courses only, right? So right, so I think this is for today. So anything, Shweta ma'am, you want to add something? Yes. I hope this session was fruitful for you guys. So I hope right. So yes, I think that is clear for you. So thank you everyone for joining the session. Now let's end this session here. Thank you everyone.